Hi guys, I hope all of you are doing good. So today we are going to look at a new topic called logarithms. Okay, what are logarithms? How it is used in mathematics to make our life easy to solve problems, right? So let's get started with what we have learned in the past. I think logarithms gets introduced in from class 8 or class 9 onwards. So kids who are in class 8, class 9 onwards, right, they can go ahead and look at this video to understand this particular chapter. Very easy chapter if you understand exponents really well, right? This topic becomes very easy. It's just an alternative to use exponents because it comes very handy to solve certain algebraic problems, for example, quadratic equations. Even your linear equations, right? At some times what happens is that we can use logarithms to solve things much faster than doing it in the algebraic format. Okay, so let's get started. So I'll just take a couple of examples in exponents to explain you guys that why do we need logarithms. Okay, so for example, let's take an example of 2 to the power 4, right? We all know that 2 to the power 4 is 2 times 2 times 2 times 2, right? Which gives us the result 16, right? 2 to the power 4 is equal to 16. What does it mean? 2 is a base over here, right? If I treat this as a person, right? If I treat this as a person, and if a person grows like 4 times of himself or herself, right? He or she will be having, it will be, he or she will be 16 times bigger than what that person was right now, right? For example, ages, we take age. For example, if I take an object also, if I can take an object and if I want to grow it 4 times, right? It is not exactly 4 times the base. For example, if I take it as a tree, right? If it goes 4 times its size, 4 times of its base, right? In this period of time, right, it will grow 16 times basically. That's what this means. Okay, so now so if we can label these, right, this is known as the base. This we know that this is an exponent, we call an exponent, or we call an indices, or we call it as a power also. All of them mean the same, that word, right? 2 to the power 4 gives me 16. And what is this one? This is your result, right? You get a result, right? The same thing can be put into a log format and shown. Okay, so what I'm going to do is that I'll take the same thing, 2 to the power 4 is equal to 16. I'll put it in a log format. Look at it. Log of base 2 16 gives me the result 4. So I'm just interchanging those values and putting it over here. Look at it. So log to the base 2 16, the value 16, right? If it has grown to 16, then how many times did it grow? That is the result 4. That is what we are getting over here. So this is how you show it as a log. The same exponent what we have learned earlier, right, in indices chapter, indices and exponents, you can put it in a log format, right? And we will get into more details around logarithms and its laws and everything, but first let's understand that how does it relate to these things. Okay, so now another thing, we have another thing called anything to the power 0 is equal to 1. Look at it. If we take 2 as a tree, right, it hasn't grown at all. It hasn't grown at all. So what happens? What is the result do you get? It will be 100% wherever it is, right? That is how we are going to read this one, right? Anything to the power 0 is equal to 1 means a person standing at the current age, right? Any person who has not grown, to the power 0 means the person has not grown. So that person is the same what he or she right now is. So that's why we have this thing as 2 to the power 0 equal to 1. Similarly, if I take a negative power, what do you get? You get 1 by 2. If you remember it from exponents, right? You get it like this. Okay. So now look at it. If a person has basically grown negatively, what do you mean? If a tree, you plant a tree and that has grown negative, what do you mean by negative growth of a tree? The tree might have died, right? The tree might have died basically, lack of your water, sunlight or something. So what happens is that it becomes half, right? It goes into the past. Now if you look at here, right, this is present, and this is past, and this is future. Look at it. So what do we understand? What do we understand by these powers? If you have a positive power, you're looking at a future, right? There will be growth. If the power is 0, right, it is present. The object or the human being or anything, right, hasn't grown. They are still the same where they were, right? And if you have a negative growth, right, you go into the past. Basically, you're losing out. So that's how we see it. So this also I can put it in a log format. Look at it. So log base 2, right? I'll put it as base over here. And if you look at log of base 2, 1 of any number is always equal to 0, right? This is one of the laws which we are going to basically learn further. Okay. Now this one, how can we write this one? Log of base again 2 of half the quantity will always be -1. Look at it here. Log of base 2 means the object, basically the object has not grown at all. The object is still there, right? The object has not grown, means basically what should be the value? It should be 0, right? That's what it's in it. Log 2, the base is 2, right? The object is 2, but it has become half now. What do you mean by that? It has gone into the past, -1. So this is how you basically understand logarithms, how to basically use it in your problems going forward. Okay, so let's move forward and learn more about logarithms. Now let's look at some examples, right? How do we show logarithms and how do we evaluate? For example, if I take an example like this, log, right? Log to the base 5, 125, right? How I am going to, what is the value going to be over here? What is the value going to be over here? Log to the base 5, it is 125. When I take the base, right, look at it. When I take the base over here, it becomes 125. Means 5 into 5 to the power something is equal to 125. What is that number? That is 3, right? So the value of this will become 3. Look at it. 5 to the power 3 is equal to 125. So we can write it like this, reverse way. Similarly, what we can do, if I take another example, say log 3, 81. Like log 3 of 81 is what? Again, how are you going to find out this one? I can write this one like this. Log 3 to the power 4. Look at it. I can break this number into exponent over here. Look at it. I can clearly see that it is 4. So you know that 3 to the power 4 is equal to 81. So this is how you show it in logarithms. Okay. This is very simple to start with, how we do problems and all those things. So now let's get into the laws. You need to understand the laws the way we had we had laws in exponents, right? You guys have learned the laws of exponents. So a to the power m times a to the power n is equal to a to the power m plus n, right? You learned all these laws. A to the power m divided by a to the power n is equal to a to the power m minus n. A to the power 0 is equal to 1. Anything to the power 0 is equal to 1. Then we learned the power law. A to the power m whole to the power n will become a to the power m times n, right? We learned all these laws. Similarly, a to the power minus 1 will become 1 by 8, right? Similarly, we have laws associated to logarithms also. They are going to use the same principles and there will be formulas over here. Okay, so let's look at it. Now, before going to the laws, right, let me show you one more thing so that this becomes easier. Now, 2 to the power 1, right, in terms of exponents is 2, right? Similarly, 3 to the power 1 is equal to 3. Similarly, what happens? If you keep going, n to the power 1 will become n, right? Yeah. And what did we learn? If I want to convert this one into log, how can I write it? Log 2 of 2 will be equal to 1. Look at it. Similarly, this one, log 3 of 3 will be equal to 1. Similarly, if you keep going on, what can I conclude? Log n of n, log to the base n, log to the base n of n will be equal to 1. So this is the first law. Remember this one. Whenever you have the base and the number same over here, right, it will be always equal to 1. This is your first law to understand even before you go understanding the laws of logarithms. Okay, so let's put it over here. So the first thing you learnt is, the first law is log of anything a. We'll take it because we'll define these formulas in the form of algebra, right? Always. We don't know what is a. A can take any value. So this will be always equal to 1. Okay. The second law states that log of to the base a, if I have a number called p, I will make it a capital number so that you don't get confused. So say p. You have this log. If we want to add two logarithms with the same base, right? If there are two logarithms with the same base but a different value, this will become log to the base a. The base is same, so I can combine these two. And what I'm going to do is that I'm going to multiply these two numbers over here. Look at it. This is similar to this one over here. Do you find a similarity over here? It's similar. If you see, I can later go ahead and prove this one that this is what it's going to be. So we will go back to that one. Now, the third one. The third one states log of a base a p, log base a p minus log base a q will be equal to, when it is p minus q, here we were adding two logarithms, here we are subtracting two logarithms. What are you going to get? You are going to get log of a p divided by q. So if you remember these formulae, right, it becomes very easy to solve problems. Okay, so these are the three main important formulas which we have, and the fourth one we'll have one more formula which is known as log of base a. Okay, log of base a, and if I have something called a to the power, I need to have the same number over here, whatever base I have, so I'll make it a little bit big, n to the power n. If I have something to the power n, the base and number are same but the power is different, so this becomes n times log a. Look at it. What is log a of a? This is nothing but it is n. So remember this one, because log a of a is 1. Log base of a, log base a of a will be always equal to 1. When I substitute that value, I get this is equal to n. So these are the four main formulae which we are going to use it in future to understand what's going on in logarithms. Okay, now let's go ahead and look at some of the examples to see that how we can use these to solve problems in algebra. Okay, yeah.